Hey there, welcome to Velotio Tech Shorts. I'm Sumant Hegde. I'm working as a senior software engineer at Velotio Technologies. I have experience in Python, backend development, generative AI, building the chatbots, and so on. In today's Tech Short, we will discuss about generative AI and its use cases. Firstly, we will see the agenda for today's discussion. Initially, we will begin with the introduction to large language models and generative AI. Then we will see the background and evolution of large language models, fundamentals of generative models, applications and use cases of generative AI, fine-tuning of large language models, challenges and limitations associated with large language models, and future trends and research areas on large language models. Okay, what is generative AI? Generative AI is a class of AI algorithm and model which is capable of generating a new content or data which is similar in the pattern of trained data, but it is distinct from the trained data set. Usually, generative AI is powered by large language models. Large language model is a trained deep learning model which is capable of understanding the natural language input, such as the input we can give in plain English. Usually, large language models are trained with very large amount of data set in terms of billions of parameters. The training data set can be of the textual information that are available on internet, some code samples, scientific papers, and so on. A single large language model is capable of doing multiple tasks, such as image classification, working as a chatbot that can be used in text summarization, and various other examples. Now, let us look into background and evolution of large language models. In 1967, Joseph Elisabeth introduced a new computer program that is known as ELIZA. ELIZA was a simple computer program that used to simulate a human-like conversation by understanding the patterns in the user's input and generating the question and generating the answer based on the input text. After that, in 1997, LSTM was introduced. LSTM stands for long short-term memory. So this was introduced to address the issue, the vanishing gradient problem that was associated with RNNs. After that, in 2013, generative adversarial network was introduced. We will discuss more about generative adversarial networks in the coming slides. Transformers architecture was introduced in 2017. They follow encoder-decoder pattern. Usually, transformer architecture follows semi-supervised learning. The term supervised learning refers to the training the model, pre-training the model with unlabeled data set, and then fine-tuning the same model with the labeled data set. In 2020, OpenAI launched a GPT-3 model, which was capable of understanding the natural language inputs and generating the output in natural language. GPT-3 was trained on 175 billion parameters. Now, let us discuss fundamentals of generative models. Initially, variational autoencoders or VAEs. VAEs follows encoder-decoder architecture. It utilizes an encoder to map the input data into latent space. It means it takes the input data and input data can be compressed or it makes the probabilistic decision from the input data and generates some data points in a latent space. And decoder takes these inputs from the encoded data and reconstruct the encoded data and generates a new output. Generative adversarial networks or GANs. GANs follow generator discriminator pattern. So what is generator and discriminator pattern? Generator basically generates a content and discriminator validates it. Generator generates a new text, image, video, or some content. And the role of discriminator is to validate whether it looks real or the generated data. Until and unless the data generated by generator looks real, discriminator keep on discard the data and the new data will be generated. Through this iterative process, Generator and discriminator learns and improve through the adversarial competition. And few other types of models are flow-based models and autoregressive models. Applications and use cases of generative AI. Generative AI can be used in text generation, summarization, search, chat assistant, image generation, video generation, audio generation, and so on. It has various use cases and it can be used in various industries as well, such as in software development, we can leverage the code generation model to autocomplete the codes and generate the review comments and generate the documentation for the codes and so on. We can utilize large language models to create the conversational teaching assistants. And in healthcare industries, we can use large language models for genome sequencing, drug discoveries, and few other use cases. Prompt engineering. So basically, what is a prompt? A prompt is a natural language text that has been inputted to large language model or generative AI model to perform a specific task. So why prompt engineering is important? Mostly large language models are not capable of considering ethical conditions, and initially it won't know what is the desired format of output and so on. So prompt basically helps to get the control for the user to get the text in desired format, desired size, and we can give the instruction to follow the ethical considerations in various ways. There are few strategies we follow to get the better results. That is called prompt engineering. Few of such techniques are single shot learning, few shot learning, providing the clear instructions in the prompt, chain of thought prompting, tree of thought prompting, generated knowledge prompting, and many others. Fine-tuning refers to the process of taking the pre-trained model and adjust its parameter on specific task or dataset to improve the performance or adapt it to a new domain where it can work and generate the new content based on the newly trained domain or dataset. So why fine-tuning is needed? No matter how many billions of parameters a large language model is trained with, it is most unlikely will be having the information that is specific to a particular organization. With fine tuning, we can train the model to gain the knowledge which is specific to a particular organization, and we can prompt and get the completion that are specific to the newly tuned data that is specific to some industry or organization or something. Fine tuning is the process that involves basically adjusting the hyperparameters, learning rates, and few other model specific parameters without losing or doing some kind of balance between previously trained dataset and the newly trained domain. It adjusts the weights between the previously trained and newly trained parameters. Challenges and limitations. Despite of having all the advantages, large language model do showcase some of the challenges and limitations. Let us discuss about biases and ethical concerns. With certain data set that was used during the pre-training of large language models, it can generate some of the biases in the generated content, and it can also generate the abusive words and etc. Lack of understanding and data dependencies. For the large language model to perform well in various tasks, it has to be pre-trained with various set of examples and very huge amount of data set. Collecting the huge amount of data set is definitely a challenge in terms of various data generation, validating the data sets, and so on. Also, it requires a huge computational resources to generate the fine-tuned model and transfer the weights, transfer the information into new weights. safety and security concerns. Sometimes models can generate very harmful content, such as code generation model generate code which is malicious, or some virus that can infect some of the systems. Some it can infect and corrupt the data of the system, and so on. And it can also generate some of the false information that can lead to misinformation of the content that is being generated. Future trends and research areas. Let us discuss about quantum AI. Quantum AI is a technique where the machine learning or generative AI and quantum computing can be combined. Next one is advanced NLP, safeguarding ethics and data security. So currently, large language models lack in data security and ethical consideration. With the future research and enhancement, this can be achieved. Multimodal Gen AI. This one is basically currently the model is capable of generating a single content, such as model can generate text, images, videos, audios, and so on. With the advancement in generative AI and the other technologies, model can become capable enough to take the input in multiple parameters and generate the result in multiple formats, such as video, audio, and image altogether. Yeah, that's all for today about generative AI and its use cases. Thanks a lot for watching the video.